So, getting started on this, we're starting chapter 6. This is the polygon angle sum theorem. It is going to be, we're going to use lots of formulas, but we're going to start with the idea behind the diagonal, and a diagonal is going to be a segment. We'll get a formal definition in a minute, but it's going to be a segment that cuts across a polygon. So something that connects like this, A to C, this dashed line right here, this is a diagonal. Also this one that goes from here on D to B, this is a diagonal. For a formal definition of that, it is going to be a segment that connects. Now, this is the word that's going to get some people. A segment that connects non-consecutive vertices in a polygon. It is a segment that connects non-consecutive vertices in a polygon. Now guys, you know I always give a definition, then I really go through and actually explain it. So when you're looking at this, the diagonals are going to connect the non-consecutive vertices, meaning one right after the other. Because guys, look right here. If they're consecutive, like A and D connect, and they make up not a diagonal, but a what? It's a segment. It's a side. It's part of the polygon. It's not going to be diagonal because it doesn't cut through. The ones that are not next to each other, like A and C, those are the ones, the non-consecutive ones like that, where they're not right next to each other, those are the ones that are going to create diagonals. Now we're going to use those diagonals to find out the degrees inside of a regular polygon. The way we're going to do that, we're going to create a bunch of triangles. Because guys, what's the sum of all the angles inside of a triangle? 180. You know that. We've done that for like 5 chapters. Okay? We know that inside a triangle, you are going to have 180 degrees. So right here, a triangle has 3 sides. Every time you have 3 sides, you get 1 triangle. And if you have 1 triangle, how many degrees is that? 180. Perfect. Let's look at it on the next shape. This is going to be a square. If we take a diagonal here and we draw it across and cut it in half with those non-consecutive vertices, we're going to have 2 triangles. So we've got 4 sides. We've got 2 triangles. And guys, what's 180 times 2? 360. There you go. Okay. Oh, and grab your calculator. If they're not on their desk, we had a folder check in my other class, so it might be under still, just so you know. Okay, here we go. Next one. We have a total of 5 sides, and if we take those 5 sides and we draw those diagonals from one single point, we create how many different triangles? 3 triangles. And if there's 3 triangles, what's 3 times 180? 540. Y'all seeing a pattern here? It kind of does the same thing every time. So now we've got 6 sides. That's going to give us, if we have that 6 sides and we draw those across, that's going to give us how many triangles? 4. And 4 times 180 gives us what? 720. Perfect. 720. Thank you. Okay. So guys, what if I came up with a generic one and I said there's n number of sides? We'll call it n because n makes sense. Number of sides. Okay. How many less triangles are there going to be? How many less is there every time?
2.
There's 2 less every time. Why? Because the 2 sides that connect to that one vertice are used for the sides right here, so they can't be diagonals. So whatever it is minus 2 is going to give you that number of sides. Minus 2 is going to give you the number of triangles. And then what do we do with that number once we get it? Multiply by what?
180.
Then we multiply by 180 to get the total amount down here. Now let's write that as a formula. N minus 2 times 180. That is going to be for the sum of the interior angles. Sum of the interior angles, guys. It's the sum of the angles inside. Sum of the angles on the inside. Guys, I would go ahead and write next to your problem. That's problem numbers 1 through 11 on your homework. It's not really 1 through 11, but it's 1 through 11. Like there's a bunch cut out. Problem numbers 1 through 11. That's the first section on your homework. Okay, that formula. Any questions, concerns, anything before we go on? Yes.
I got two questions. Is
Yeah.
it always going to be 2?
Is it always minus 2? Yes.
And
Absolutely.
Oh, never mind.
Okay, that took care of it. Okay. Yes, guys, ask, please. The formula is always minus 2, and the reason it's always minus 2, look at this. If I've got a point right here, there's always two sides that are connected to it that can't form triangles. They can't make diagonals. Okay?
When do we use it again?
Anytime we're trying to find what's called the sum of the interior angles. And on the homework, that's going to be 1 through 11.
So
Okay.
I would do 6 minus 2.
Mm-hmm. So this would be like 6 minus 2 times 180.
Okay.
Absolutely. Guys, ask. We have an example of it coming up. That's what we're about to do, but I'll answer it. Okay? Okay, guys, here we go. I'll show you what it looks like. Now, before we go on, I figured out that they didn't know these, so we need to write these down and make sure you have them. It's going to take you a minute, so please take a second and write these down, because if you don't know, you're supposed to know this before you get here, but if you don't, now's the time to get this list in your head. Okay, triangles are three-sided. The generic name for four-sided is quadrilateral, because guys, a four-wheeler is called a quad. Anything with four is called having quad. Quadriplegic means you can't use the four limbs. I mean, there's so many things that are connected to that four. Thank you, sir. Appreciate it. Grab the notes just so you don't have to get back up again. Okay. So quadrilateral is any four-sided figure. That includes squares, rectangles, parallelograms, anything that's got four sides. Pentagon is 5, like the building that the planes went into on 9/11. That's a pentagon. The pentagon is the big one with all the security stuff for the U.S. government. Okay. Hexagon, it's a pretty common shape. You think of it associated, I know it's funny, but it's associated with bees and their hives. That's where a lot of that is associated with. Most people don't know 7. 7 is called a septagon. S-E-P-T-G-O-N. Septagon. Okay, if you'll just put it in the basket face down, it doesn't have any makeup word listed at the bottom. Okay, perfect. Thank you. And you've got the worksheet, and have fun. Okay? Okay. And then we get to 8. Everybody knows 8. It's what a stop sign is. It's an octagon. Everybody remembers it because they think of an octopus. That one's not usually one that I have a problem with. 9 is a nonagon. That's the one we're going to do right here. So that is definitely one that a lot of people don't know. Nonagon is 9. Guys, what's a word like a decagon for 10? What's a word that we use all the time that goes with deca? Decade. A decade is 10 years. Okay. Now, 11 does not have a special name. Listen to me. 11 does not have a special name. It is literally the number 11 and a dash and G-O-N. There aren't many of them in the world. There aren't many things with 11 sides on them. So you're not going to see that very often. The next one is 12. It's the last one that has a special name, and that is a dodecagon. Guys, what's do mean? Like dos in Spanish means what? 2, and deca means 10. So 2 and 10 is a total of 12. That's where it comes from. Dodecagon. 2 and 10. That's the last one that has a name. Everything beyond that is just a 13gon, 500gon, negative, whatever. It can't be negative. Can't have negative sides, but 22 over 7gon. I hope you don't have that, but okay. Yes.
Numbers right next to you. That is
Decagon. D-E-C-A-G-O-N. Decagon. D-E-C-A-G-O-N. Please ask, guys, if you don't know. Thank you for asking. Alright. Anybody else before we try some of the problems? Say it one more time.
Is it called
Nonagon. N-O-N-A-G-O-N. Non-agon. Anybody else? Guys, please ask. I have no problem answering. Okay. So we're going to start with the nonagon. A nonagon is a 9-sided figure. We're going to find the sum of the interior angles. And if we're using the sum of the interior angles, that's the formula we just did. That's that n minus 2 times 180. What's the n going to be in this case? 9, so it's going to be 9 minus 2 times 180. Now, listen to me. I want you to try something on your calculators because I want you to see why it can cause you a problem. Try typing in 9 minus 2 times 180 just straight through. 9 minus 2 times 180. What's it give you? A negative, a decimal. It gives you lots of things. Your calculator doesn't like it, guys. Guys, the reason is because this is inside of a parentheses. You must get this answer first. So you've either got to type the parentheses in, which is a lot of work, or you can just hit equals after you do the 9 minus 2. So this would be 9 minus 2, which is 7 times 180, and then 7 times 180 is, what was it? 1260. Thank you. 1260. Appreciate it. Alright. Now, we can do the exact same thing going backwards. You will see a couple of these along the way, but not as often. Okay, not as often, but you will see them every once in a while. But this is the exact same formula as this, except instead of giving you the number of sides, it gives you the sum. It gives you the answer. So the sum is 1620, and that's going to be equal to that n minus 2 times 180. We're still using that sum formula. Still using that. N minus 2 times 180. Now guys, how do I undo this multiplication? What's the opposite of multiplication? So we're going to divide both sides by 180. Grab your calculators, do 1620 divided by 180. 9 equals, now when you bring this down, guys, you canceled out the 180. When you bring those down and cancel out the 180, you don't need the parentheses anymore. You're not multiplying by anything. Then from there, it's just a plus 2, and that'll tell you that you got 11 sides. 11 sides. The number of sides equals 11. Right. Any questions, concerns, anything about that before I move on from that just interior formula, just a regular sum formula? Okay. Now there is this special thing when you deal with a regular polygon. Now remember, regular polygons we've talked about before, but we'll remind you what that means. We're not going to give you the full definition, but let's remind you. Regular polygons are going to be like a square. Right? So they are going to have all the same sides. What's the word for all the same sides? What was it? Not quadrilateral. That is a quadrilateral that has 4 sides all the same, but the generic name for it is equilateral. That was specific to the 4, but yes, equilateral. If it's equilateral, then all the angles are going to be the same. That's that weird word that we talked about, and it is not equidistant, but that was a good try. It was one of our words we had. It's called equiangular. All the same sides, all the same angles.
Is it 2 A's or 1?
I think we decided it was 1. Didn't we look it up and decide that last time? I think it's just the 1. Now you're going to make me look it up again. Because we did this last time, because I can't spell at all. It is, oh no, remember it's got an I in it. Where's the I? It's after the U. That's what it is. It's not that it has another A, it's that it has an I. Thank you for saying. We looked this up last time and we corrected it last time. I should know that. Didn't we do this the last time we did notes on this? I think we did. Okay, so guys, all that means is that all the sides are the same and all of the angles are the same. That's like an equilateral triangle. Guys, where do we see an equilateral triangle all the time on the road? What sign is an equilateral triangle? Ooh, y'all haven't taken your road sign test? Come on, you should know this. Yield, thank you, that is correct. A yield sign is an equilateral triangle. What's an octagon? What sign? Stop sign. Very good. So, and what are all speed, they're not regular, but what are all speed limit signs? Rectangles. Good. Good. I'm trying to think of any of the other shapes. I don't know of any others. There's one that's a diamond, but I can't remember what it is. Don't they put like the smoke and fog ones on the diamonds, on the squares, just turn sideways? That's all they really are. I think they do. Okay, guys. So from here, oh yeah, please.
What does that say on the regular polygon?
Equilateral and equiangular. Equilateral, meaning all the same sides, and equiangular, which means all the same angles. Okay, anybody else? Okay, so guys, if you can find the sum, then you can find one angle. It's the exact same formula. You do the exact same work. The only difference is that you're going to divide by the number of sides. That's it. Bless you. You're going to be using this formula on problem numbers 13 through 23. Again, it's not really 13 through 23 because I cut a bunch of them out, but that's the problem numbers you're going to use it on. Okay, 13 through 23. Now, this is a work backwards problem of this. I'm going to say this again. This is not going to be on the assignment, but I need you to see one going backwards like this because the EOC is going to have some. It's going to always do the thing that's the most involved. So get this one down and let's talk about it. It says the regular polygon has an interior angle, that's this, one angle, of 135 degrees. So it's 135 equals, and then here's our formula. N minus 2 times 180, all divided by n. Now we want to get that n off the bottom. Guys, how do we get rid of any denominator? If we have a denominator, what are we going to do to both sides? Multiply. And what are we multiplying by now? N. We're just multiplying by n. Good. So that n is going to cancel. We're going to get 135n equals n minus 2 times 180. Guys, just like we did on the other, it's exactly like this one now. You do the exact same steps now. So how did we get rid of the 180? What's the opposite of this multiplication? Division. Divide by 180. Divide by 180. That's going to make it, it's like a decimal. I don't know what it is. Y'all have to tell me. 0.65? 75. Sorry, that's me not here. 0.75n equals n minus 2. Again, once you cancel this out, the n minus 2 do not need parentheses anymore. You're not multiplying by anything. Then the only thing we have to do now is get all the n's to one side. Now, be careful. Guys, the 2 is over here. I need to get away from the 2, so I need to move this n. It's a positive n, so I'm going to subtract n from both sides. What am I actually typing in the calculator? Minus what? Minus 1. So it's 0.75 minus 1. That's going to give you, I think it's like negative 0.25. N equals negative 2. Divide both sides by negative 0.25. Now the negative takes care of itself. A negative divided by a negative is a positive. The negative takes care of itself. But what is 2 divided by 25, or 0.25, I'm sorry. N would equal what?
8.
8. And 8 is what? What does 8 tell you? It's the what?
How many sides it has?
Thank you. Perfect. It's the number of sides it has. Do you see it's not anything really terrible to do? It's just, I need you to see that it's just one more application. I don't even think there's a problem like it on your homework, but I need you to see that they can ask these questions in so many different ways. Okay, bless you. Anything before we go on? Anybody else? I just want to make sure before we head out. Okay, with a short period, if I need to go back, I will, but I want to make sure I get through these. So, and give you time to work. So here we go. If you have these pictures, this is going to be like problem numbers 25 through 35. 25 through 35. Again, not really, but you get the idea. 25 through 35. You're going to start by finding the total inside here first. Now, guys, I know we know what the answer is to this, but I'll show you how to do it no matter what. You're going to do n minus 2 times 180. That's the total inside them. We just use that on 1 through whatever, 11. Okay? N minus 2 times 180. That'll give us the total inside here. Well, how many sides are there? 4. And 4 minus 2 times 180 is going to be 2 times 180, which would be 360. Now y'all know that every four-sided figure adds up to 360, but in case it's any other shape, you can use that formula. Okay? Okay, guys, this is a simple equation. We're going to add the x and all these other things together. Now, we can go ahead and add these up. Grab your calculators. We can add up the 93, the 88, and the 42, and put x plus whatever that is equals 360.
X plus 223.
223, perfect. X plus 223 equals 360. We would then just minus 223 from both sides. That would make it x equals, and if we do 360 minus 223, it's going to be 37?
Yep.
37? There you go. Now guys, when you plug this one back in right here, it's just 137. There's no solving it, no doing anything. The next one's not like that. It has more complicated things when you do the next one. So, anybody before we go to the back? The back's easy. This is the exterior angles are a joke. It'll be the same thing when you do the worksheet. The back of the worksheet's easy compared to the front. Okay, here we go. So from here, we're going to do the same thing, but we are going to have how many sides? You got to know how many sides before you start anything. 6. So it's going to be 6 minus 2 times 180. 6 minus 2 is going to be 4 times 180, which is going to be what? 720? Thank you. Perfect. So our total is 720. So guys, we're going to add all the variables up. We'll start with that. 3, 4, 4, 2, 2, and 3. Add all those up. Tell me what you get for the variables. 18, x. And then we're going to combine all of the numbers. Ooh. We figured this out earlier though. Guys, what happens to the negative 10 and the positive 10? And then the negative 20 and the positive 20? Cancels out. So it's just 18x equals 720. If you divide both sides by 18, that's going to put you at x equals, and then we're just going to do 720 divided by 18. What's that give us? What does it give you? I think it's 40. Check. Just do the math real quick. It is 40? Okay. So then, guys, this one's a little bit more involved because this one you just can't put that as the answer. You've got to actually go through and plug it back into all of them. So when you go to plug it back into all of them, the first one is 4 times 40, which would be 160. The second one is the same, so it's just going to be 160. The third one is going to be 2 times 40 plus 20. That's going to be 80 plus 20, which is going to be 100 for the third one.
Wait a minute. So we gotta go back and.
Say it one more time, huh?
We gotta go back and put the numbers into each.
Yes, because it says to find the missing angle measures. On the last one, the only missing angle measure was the x, so you didn't have to do anything. X is your answer. On this one, you got to plug it into all of them to get all the different angles. It's a very good question. Keep us going, guys. 2 times 40 plus 10 is going to be 80 plus 10, which is going to be 90. 3 times 40 minus 20, nope, not 12, minus 20, sorry. That'd be 120 minus 20 would be another 100. So we got 100 again, guys. That's the second 100. And then we got one more. 3 times 40 minus 10 would be 120 minus 10, which would be 110. That's our last one. So on the answer blank, this is what you would write for the answer to the question. A lot of y'all struggle with what is the actual answer to the problem. You can get all the work right and you don't know what the answer is. That's what they were asking for, those missing angle measures. All right, we talked about these go with problem numbers 25 through 35. Now, the rest of them go with what's on here. We've got the last of this. It's going to be the interior and exterior, the exterior angles, and finding the interior and exterior from one thing. Exterior angles are easy, guys. They're really consistent. They're really straightforward. So hopefully it'll make sense to you once you see this pattern. Let's take a look. So here are exterior angles of regular polygons. Guys, look right here. I've got 3 exterior angles on any triangle. Okay? Each one of those exterior angles is 120, and there are 3 of them. What's 120 times 3? 360. Okay, then on this on this square, you're going to have 4 right angles on the outside here. So on these 4 right angles, each one of them is 90, and there are 4 of them. And what's 90 times 4? And then on this pentagon, each one of the exterior angles is going to be 72. And 72 times 5 is going to be 360 again. Guys, y'all seeing a pattern here? No matter how many sides it has, doesn't make any difference. The number of sides doesn't matter. It could be 500 and the exterior angles will still add up to 360. Every single time they're going to add up to 360. Guys, I even wrote it down on the beginning of the next slide. It says the exterior angles of a polygon will always add up to 360. So let's take a look. So again, the exterior angle sum of any convex polygon is going to be 360. Because it's always 360, you can find an exterior angle by just dividing 360 by the number of sides. So if you want to find the exterior angle, you're just going to do 360 divided by the number of sides. That's it. Exteriors are really easy, guys. Really easy. And if you want to cheat and get the interior after you have this formula, interiors and exteriors have to make a straight line. You can see that. Let's flip back real quick. Guys, do y'all see every single one of these? The interior and exterior makes a straight line here. So they're always going to add up to what? 180. So because of that, if I want to find the interior angle after I have the exterior, I can just say 180 minus that exterior, and I'm going to get my interior angle. It's kind of a backwards, like a cheat way to get the interior, really easy. If you want to get the interior and exterior, this is the easiest way to do it. 360 divided by the number of sides is going to give you the exterior, then subtract, that'll give you the interior. Okay, so here we go. We want to find the exterior angle of a regular octagon. How many sides does an octagon have? 8. So it's going to be 360 divided by 8. And how big is each one of those exterior angles going to be? 45. Okay, these guys are going to be like problem numbers 37 through 43. Again, not really that many problems, just where the numbers are. For the next one, it's a pentagon. How many sides does that have? 5. So it's going to be 360 divided by 5, which is going to give us what? 72. There you go. Okay, we got one last slide. I think there's one more of exterior. Okay, guys. So when you use exterior, you can manipulate with 360 in all different ways. This kind of just shows you that you can work it backwards and you still get the same thing. It says the measure of the exterior angle is given. So this is the exterior angle, guys. They want to find the interior angle. Now, guys, I already told you how to find that. If you have the exterior and you want to find the interior, all you do is subtract from what? So 180 minus that 24 is going to give you your interior angle of what? Is it 156? There you go. That's going to give you your interior angle. But it also asks you to find the number of sides. How can I find the number of sides? Yep, 360 divided by 24, divided by the exterior angle, and it's going to give you the number of sides. How many sides does it have? 15 sides. Good deal. And that's like problem numbers 49 through 57. It's not really 49 through 57, but you get the idea. Just so we have a direction. Okay, guys, so that's our notes for today. I'll get you started. They actually were getting a lot of it done before we left. We'll see how it goes because we do have our shortened period. What time do we get out of here? 19. So we got about 10 minutes to work. Okay. So let's get you working. See how many y'all can try. I would try like a couple in each section. Okay. Yes. Just tell me when I get back up there so I don't forget. Yes, you do. Oh, did you see that sheet up there for when you're gonna be out in the future? They sent me that email, so go grab that. I don't know what day that is, but they told me you were gonna be gone. That's what they said. I don't know, that's what they said. I got an email that said you were gonna be gone. I don't know why, but it said you were gonna be gone. Okay. Colton, put the purse away, put the phone away, come on. Come on. Come on. Okay, guys, listen to me. Try a problem from each section. Try one. It won't take you long to see if you're heading in the right direction or not. There's a key up here. Use it. Okay? Feel free to take a picture of it. It's just answers. Okay? But use it. Figure this stuff out. See if you understand what you're doing. You gotta show work to get credit. These go very quickly. Once you get in the routine of what you're doing, they go fast. You know what it is now? Okay, I don't know what it is. I just know I was told that you were going to be gone, so I wanted to make sure you had what you needed. Okay? So grab that. Which slide? First one? That one? Okay. Bless you. Anybody gonna answer number 1 yet? Almost. How many sides does it have? 8. Problem number 1. Oh, no, y'all are doing number 5. Problem number 1. How many sides does that shape have right there? 8. So 8 minus 2 times 180. What's that give you? I just want to see if we can get an answer right. 1080 is correct. Good. 1080. Hold on one second.